Hello, everyone, and welcome to Techie. Today, we're going to talk about a real unsung hero of networking, the layer that stops a total disaster from wiping out a huge file download right at the very last second. So let's just jump right in with a scenario that I think we've all had nightmares about. You're transferring a massive, super important file. You've been watching that progress bar for ages, it hits 99%, and then boom. Your connection drops, or maybe the whole computer just crashes. What happens then? Now, you'd think the network would catch this, right? The lower layers might even send back a little success message for that final chunk of data. But here's the really tricky part. What if the destination computer crashes a millisecond after it gets that data, but before it's actually saved from memory to the disk? Well, that last crucial piece of the puzzle just vanishes. And the sending computer, it has absolutely no idea. It thinks the job is done and moves on. But now, your file is corrupt and totally useless. This isn't really a network failure, it's a synchronization failure between the two applications. To solve this exact problem, the folks who designed the theoretical OSI model came up with a specialized manager just for these kinds of digital conversations. Layer 5, the session layer. Its main job is to be the dialogue controller. It handles the entire life cycle of a conversation between two apps, from the initial hello to the final goodbye, making sure the whole exchange is orderly, managed, and can recover from problems. Okay, so how does it actually do all that? Well, we can pretty much break down its responsibilities into three main jobs. First up is session management. This is the basic work of starting, maintaining, and then properly ending the connection. Next, you've got dialogue control, which is kind of like a moderator, deciding who gets to talk and when. And finally, synchronization. And this is the really brilliant solution to our file transfer nightmare. Let's look a little closer at dialogue control. This function basically sets the rules of engagement. It can enforce a half-duplex mode, where the apps have to take turns talking, just like a walkie-talkie, or it can allow for full duplex, where both sides can talk and listen at the same time, like a regular phone call. The session layer is what manages this whole process. And this brings us to synchronization. To avoid that whole starting from scratch problem, the session layer can actually insert checkpoints right into the data stream. Honestly, the best way to think about these is like putting bookmarks into a really, really long book. So this means if our huge file transfer fails at 99%, the applications don't have to start all the way back at 0. Nope, they can just agree to roll back to the last confirmed checkpoint, maybe at the 95% mark, and pick things up from there. It's a simple idea, but it saves a massive amount of time and bandwidth. Now, this all sounds incredibly useful, which brings up a pretty obvious question. If this layer is so important, why don't we hear about it all the time, like we do with the transport or application layers? Well, the answer really boils down to theory versus practice. The OSI model is a brilliant theoretical framework, but in the real world, with the TCP/IP model that actually runs the internet, the session layer is often called a thin layer. And that's because its jobs didn't go away, they just got absorbed by the layers around it. So instead of having one dedicated layer, its key functions got split up. A lot of the reliable connection management, for instance, became a core part of TCP, down in the transport layer. Meanwhile, other things like dialogue control and synchronization got pushed up into the application layer, which lets individual programs handle them however they need to. But, and this is really important, just because it's not a separate layer in the TCP/IP model doesn't mean the concepts just vanished. In fact, the problems the session layer was built to solve are probably more relevant today than ever. The spirit of the session layer is alive and well in the tech we use every single day. Just think about it for a second. A video call has to perfectly sync up separate audio and video streams. When you log into your bank's website, it creates a secure session that remembers who you are from page to page. These are all examples of a stateful dialogue, a conversation that has context and memory. A perfect real-world example is the remote procedure call, or RPC. This is a huge deal in modern software. In simple terms, an RPC is just a short, managed session where one computer asks another, "Hey, can you run this function for me?" and send back the result. That whole request and response is a controlled dialogue. And remember that video conference? Well, every time you join one, a protocol called SIP, that's the Session Initiation Protocol, is working hard behind the scenes. Its entire job is to establish, manage, and terminate the call. I mean, that's a perfect modern example of a dialogue controller, right?
So here's the real takeaway. While the OSI model's Layer 5 is mostly a theoretical idea these days, its problem-solving DNA is built right into the applications and protocols we all depend on. The problems didn't go away, so the solutions just found a new home.
And this kind of leads to one final interesting thought. As our systems get more and more complex and distributed, with tons of little microservices all trying to manage complicated conversations with each other, are we basically just rebuilding the session layer all over again, but inside our software? What do you think? Is history sort of repeating itself here in our modern cloud architectures? We would genuinely love to hear your perspective on this, so please share your thoughts down in the comments below. And of course, if you found this breakdown helpful, please do us a favor and hit that like button and subscribe to Techie for more deep dives into the technology that shapes our world. Thanks for watching.